guys to another episode on ASUG 12 exams. So this is the 16th episode in a series of episodes that are focused on looking at the November 2022 Science Paper 2. So if you haven't seen the other 15 episodes, please check out on our YouTube channel. Remember, extensive revision is key to your success in any exams. So let us look at the last question, which is C3. Ethanol is a product of main fermentation reactions. The molecular formula of ethanol is C2H5 then OH. Question A, draw the displayed molecular structure of ethanol, and that's 1 mark. So let us answer question A, which just requires us to display the molecular structure of ethanol. So A, the molecular structure of ethanol, which has this formula C2H5, then we have like this. It will be C, this is the C bond, then we have the hydroxyl group there, which is the alcohol functional group. Then we have H here, then another hydrogen here, then another hydrogen here, then another hydrogen here, then another hydrogen here. Once you do this, you are good to go. So what is key is the functional hydroxyl group and ensuring that there is no double bond. Remember, double bonds are only in the hydrocarbons which are unsaturated, which are alkenes, and this group follows this generic functional group in case you are asked to write a formula of N given the number of carbons. You need to remember this formula. Question B, when ethanol is heated with potassium dichromate 6, it is converted to ethanoic acid. What type of reaction is this? So the type of reaction in this case is known as oxidation. So this is an oxidation reaction. So what is happening is to this ethanol we are adding oxygen. So the formula will be like this. So for B, this is oxidation. The equation will be like this. So I'm going to use a different structural formula by using an isomer of ethanol. So we have C. This is done in order for you to easily follow what is happening quickly. But I can give you both cases. So we are adding 2 oxygen from the oxidizing agent, which is potassium dichromate. Then we are going to get ethanoic acid, which is by this plus water. So what is happening? This one oxygen is replacing these 2 hydrogen. Then these 2 hydrogen plus 1 oxygen from here, they are forming water. Then we are going to get this ethanoic acid through the process known as oxidation. So we are adding oxygen to this alcohol. Alternatively is the case where we expose the alcohol to the air for a long period of time. Then we are going to have another equation using now the second isomer, which is this standard formula. Then we react it with oxygen because it's exposed to the air for a long period of time. We are going to get this ethanoic acid plus water. So now this oxygen from the air is reacting with this one by oxidation to give us the same equation, which is the same as the case above. Question B, Roman numeral 2. Give one safety rule to be observed when handling ethanoic acid in the laboratory. So the question requires us to give one safety rule. So let us just create space. I'm going to give you a number of them. Then you can just choose one, which is B Roman numeral 2. So number one, you need to avoid excessive in-airing of ethanoic acid, just like N acid. Ethanoic acid in vapor. So this vapor can be very bad for your health. Number two, which you can give, keep the mouth, which is your mouth, away from the mouth of the apparatus. So the apparatus or the ethanoic acid. Remember, ethanoic acid is also known as acetic acid. Number three, what you can say, do not use laboratory burners when handling ethanoic acid. Just like any acid, do not use the burner. Number four, what you can give, remember you just have to choose one. Never smell ethanoic acid, just like any acid, do not do that. So these are the safe rules that you can choose from to ensure that you get the optimal marks from this question. Let us look at question C. Ethanoic acid reacts with ethanol in the presence of a catalyst to produce a new substance. Give the name and deduce the formula of the new substance. So ethanoic acid is reacting with ethanol in the presence of a catalyst to give us a new substance. Then the question is, what's the name of the product which is produced, and deduce the formula of the substance. So if you look at the question, you notice that this is a standard case where we say a carboxylic acid, we react it with an alcohol, we get an ester plus water. So this is the process known as esterification. So we are reacting ethanol with ethanoic acid. So ethanoic acid is given by this is a 3. Then we react it with this is in the liquid state, we react it with ethanol, which is given by this. I'm going to use this structural formula, which is also in liquid form. Then what do we get? We are going to have a reversible reaction. So we are going to have this H is replaced by this part of ethanol. Then this hydroxyl and this hydrogen forms water. So we are going to have then CH2CH3 then plus water. So this is the product. Then this is also another product. So we have ethanoic acid here plus ethanol. Then we end up with ethanoate plus water. So the name of the product is ethyl ethanoate. That's the name of the product. Then this is the formula, as the question asks us to deduce the formula of the new substance. So that's how you answer that question. Question D. Ethanoic acid is a weak acid. It can react with a metal such as sodium and magnesium to liberate hydrogen gas. Compare the rates of reaction of ethanoic acid with sodium and with magnesium. So we want to compare. So you notice that in the activity series, sodium is higher than magnesium. So the rate of reaction between sodium and ethanoic acid will be faster than that of magnesium, because sodium is more reactive than magnesium. So question D, Roman numeral 1, the rate of reaction between sodium and ethanoic acid will be faster than the rate of reaction between ethanoic acid and magnesium, because sodium is more reactive than magnesium on the reactivity series. So when we react sodium with ethanoic acid, the rate at which hydrogen will be released will be faster than that of the reaction between magnesium and the ethanoic acid. Let us look at Roman numeral 2 of D. What would be observed when aluminium is added to ethanoic acid? Give a reason for this observation. So ethanoic acid is a weak acid. Then we have aluminium, which is less reactive than it appears on the reactivity series. So what will be observed is when you add aluminium, no clear reaction will be observed. Why is that the case? Because though aluminium is placed higher than hydrogen in the reactivity series, it is protected by a thin layer of oxygen, unless it's clearly indicated that this is a pure aluminium. But N aluminium has a thin coat of oxide, which makes it to be less reactive than it should be. So let us answer this question. No observable reaction is observed when aluminium is added to ethanoic acid. Then the next question, why? This is due to the protective thin layer of oxide which cannot be easily seen with eyes, which make aluminium less reactive than it is placed on the reactivity series. Once you do that, you are good to go. D, Roman numeral 3, give one use of aluminium based on the observation made in D, Roman numeral 2. So you have to be critical and connect these two questions that are related. So if here you answer that there is an observable reaction, then it will be difficult for you to answer this question. So because aluminium is less reactive than it's supposed to be, it is used in main industry. So most of the thing that it is used for is like TV areas, because it's less reactive. So even if you have acetylene, it will not react because that will be weak acid unless it's a strong acid. Then it is also used for satellite dishes, ladders, forks and cans where you put those carbonated drinks, beer kegs and aeroplane parts. So you can just choose one. So let me just list them. So Roman numeral 3 of D, you have used in things like 1, forks, cans, these are food cans. You have ladders, TV areas, satellite dishes, kitchen utensils. Just choose one. Beer kegs, You also have aeroplane parts. So just choose one of these. So these are the key uses that you can think around when you're answering this question. So thank you for joining me in this episode, and this is where I've come to the end of this series of episodes that has focused on this paper. So if you haven't seen the other episodes, remember to check on our YouTube channel. We've answered all the science papers for 2022. That's internal and the GCE, and all the papers for mathematics, and also for the other previous 5 years. Remember, your success depends on extensive revision.